MetraWeather is a Python-based desktop weather application that provides real-time weather forecasts and historical weather data for locations across the Philippines and other countries. Utilizing data from the Weather API, MetraWeather offers users a sleek interface to view up-to-date weather conditions, including temperature, wind speed, humidity, and precipitation. The features of MetraWeather application are the following: current weather forecast. Users can access a 7-day weather forecast for any allocation in the Philippines and other countries. Historical weather data. It retrieves and reviews past weather conditions by specifying a particular date. Data persistence. It ensures data persistence by storing weather information in a local SQLite database, allowing for offline access and historical reference. Customizable locations. Users can also input any city or region within the Philippines and other international locations to receive localized or international weather details. User-friendly interface. It has a user-friendly interface designed for simplicity, providing an intuitive and straightforward user experience. And lastly, alert system, which notifies the users for severe weather conditions for their selected locations. The technologies that are being used are the following: Python for our main programming language, SQLite for our database, WeatherAPI for our source weather data, and Tkinter, which is a Python library for creating our graphical user interface.
The MetraWeather application is an advanced solution designed to deliver a real-time weather updates and extended forecast for a specified location through an intuitive graphical user interface, built using the Tkinter library and custom extensions. Core functionalities involve interacting with the Weather API, facilitated with the Weather API class, which retrieves weather information using a dedicated API key. Notably, the application supports fetching both current and historical weather data, with a seamless integration process into an SQLite database named weather_data.db. The GUI structured with distinct frames ensures an engaging user experience. For the programming technique, the Weather application employs object-oriented programming principles to organize and structure its codebase, enhancing modularity, maintainability, and code reuse. The Python programming language facilitates the implementation of OOP, and the application is structured around several classes that encapsulate related functionalities. The central classes include mainframe, second frame, weather frame, detail frame, data frame, alert, and Weather API. Each class corresponds to a specific aspect of the application's functionality, contributing to a modular and well-organized design. API integration. The heart of the application is the Weather API class, responsible for interacting with the Weather API. The API key is stored within this class, API_key. The class includes methods for requesting both current weather forecasts, request forecast, and historical weather data, request previous forecast. Upon a successful API request, the fetched data is stored in a local SQLite database. Database storage. The SQLite database named weather_data.db serves as a crucial component for storing and organizing weather-related information. The database design follows a structured approach with multiple tables tailored to store specific types of data. These tables are locations table, forecast table, conditions table, and astro table. GUI components. The graphical user interface of the Weather application is structured around several distinct frames, each designed to fulfill a specific role and contribute to the overall user experience. The use of frames allows for a modular and organized layout, enhancing the clarity and functionality of the application. The custom Tkinter library is utilized to build and style these frames. This library extends the functionality of the Tkinter library by providing custom styled widgets, enhancing the visual appeal and coherence of the GUI. Application flow. The app class serves as the main application window. Upon initialization, a logo and application label are displayed for a brief period, providing a visually appealing introduction. Threads are employed to manage the transition between frames, allowing for a delay before revealing the main components of the interface. The side frame handles navigation, providing buttons to switch between different views, current weather and forecast, previous weather information, and an exit button. Coding conventions. Variable naming. The code adheres to PEP 8 naming conventions by using descriptive and meaningful variable names. This practice enhances code readability and comprehension. For example, variables like location ID, forecast ID, and max temp are named in a way that clearly indicates their purpose within the context of the application. Comments. The inclusion of comments throughout the code serves to provide additional context and explanations about the purpose and functionality of different sections. By following these coding conventions, the codebase becomes more maintainable, collaborative, and less prone to errors.
Main.py. This file creates the main window of the weather application. It is like building the frame of a house. It sets up for the overall structure. It gives the window a title, sets its size, and adds a logo, image, and label that will display when you first open the app. It creates 3 different frames or views. There is the main frame, the side frame. At the main frame, this will show the default weather forecast view. Then the second frame, this will show the historical weather from past dates. Side frame, this will have the button switch between the main and the second view. Mainframe.py. With the structure built from the main.py weather data delivered from weatherapi.py, these files create and display the default weather forecast script. It imports GUI component and Weather API code. It defines a mainframe class that inherits things like layout properties from custom Tkinter class. You can think of this as a blueprint for building the main view room. Next is second frame. Imports. This section imports various modules and classes necessary for functionality of the code, including custom Tkinter elements, frames for displaying weather data, threading for running tasks in the background, date and time for managing dates, Weather API for fetching weather data, and other necessary libraries. For class second frame, this class defines the structure and behavior of a frame within the application. It inherits from ctk.ctk frame, likely a custom Tkinter frame. Inside the init method, it sets up various UI elements like entry boxes for location search and date input, labels for message and weather information, and frames for displaying detailed weather data. The methods. For content, it updates and displays the content with the new weather data. Set label text generates the appropriate text to display weather forecast date and location. Delete message text is intended to delete the message after a search operation. Search triggers the search operation in a separate thread when the user hits the return key in the search entry. Request method is the core of the search functionality. It fetches weather data from API based on the location date it handles. Last is the data frame. The imports and data frame is custom Tkinter for UI elements, PL Python image library for image manipulation, and date and time for handling the dates. In init method, setups the frame and initialize some variables, creates headers for different weather attributes. In content display, takes in data and updates the display based on the received forecast data, parses the forecast data for different attributes like date, time, temperature, wind, and precipitation, updates the label and icon in the GUI according with this data.
Moving forward to the database integration, MetraWeather uses SQLite version 3.43.0 that is already built in the PyCharm IDE. To start interacting with a centralized database, it is necessary to run this database setup.py once to establish a database connection and create the database schema. Since this is a weather system, we created the following tables: the locations table, forecasts table, conditions table, and the astro table. We already have an existing database here, but for a cleaner demonstration, let's re-execute this Python script. A new data source named Weather Data Demo will be created here. If you expand it, you will see all the 4 tables created previously. Now, let's open them to see the contents. All of the tables should be empty by default. Because of the vast amount of weather data we can get from the API, MetraWeather is only designed to apply a transactional database, as per Sir Haji's suggestion. That is, whatever location the user searches within the application, its corresponding weather data will be stored in the database. And that specific feature is implemented in this WeatherAPI module. This WeatherAPI class connects to the established database, contains methods to request current, previous, and future forecast from the API, and stores all the forecast data into the database. Now let's launch the application. Let's try searching for current weather data, for example, Manila, and hit enter. So, as you can see in this graphical user interface, this uppermost part summarizes the current weather. It displays the cloud condition, maximum wind speed, total precipitation, average pressure, and average temperature in degrees Celsius. MetraWeather also displays a more detailed information below. This includes of course the search location, sunrise, sunset, moonrise, moonset, maximum and minimum temperature. We also have the icon here, temperature, wind, precipitation, cloud, humidity, and pressure for the whole day in a 3-hour interval. Next, let's see the future weather forecasts for the next 6 days. Browsing back to the database, let's reload it to see updates. Now, Manila is already in the database. Let's check the other tables. Reloading the forecast table, you'll see Manila's weather forecast for 7 days with its corresponding data such as max temp, min temp, average temp, total precipitation, and max wind speed. The conditions table will store more weather conditions data, while the astro table will contain the sunrise, sunset, moonrise, and moonset data. Let's try searching another location. Let's check the current weather condition for Vigan, and browse for the next days. MetraWeather isn't just limited to local weather conditions in the Philippines. It can also search for international places like, for example, Sydney. We can also try for Milan and check its corresponding 7-day weather forecast. Now, let's reload the database to see all the updates made. And there you have it. For the alerts, it's a little bit difficult to showcase this feature since not a lot of places have it currently. But let's try this one we found earlier. Ontario. This alert feature will display the headlines, severity, urgency, areas affected, event, and a more detailed description of the alert. Moving on to the previous weather feature. Let's search again for Manila on October 30th, 2023. Once entered, all the weather data for Manila on that specific day will be displayed. Let's once again check the database to see updates. Manila is already in the database with location ID of 1, so no new row will be inserted in this locations table. Let's check the forecast table instead, and sort it by location ID in ascending order for easy browsing. You can see that a new date 2023-10-30 is already inserted here. Let's search again. This time, a new place like Paris on November 15, 2023. Reloading the locations table again, a new row for Paris will be added and assigned a new ID. Browsing through the forecast table all the way to the bottom, we can see that a new row is also added here for Paris with date 2023-11-15. I guess that's pretty much it for the demonstration of MetraWeather. Thank you for watching.